What does IoT have to do with beer? Quite a lot, actually, when you turn your eye on the world's leading brewery group, AB InBev. They transform the brewery of the future with the Internet of Things technology and enable a flexible, productive and sustainable operation. Let's look at some best practices from them as today's digital pioneers and focus on use cases to increase productivity. I'm curious to see how industrial providers support their goals in this. So you should stay tuned if you want to know the first-hand use cases for productivity, you want to find out the secret of the brewery of the future, and if you like beer, of course. So welcome to our IoT Industry Bartalk episode 3. Let's start and cheers to our guests. So hi Wim and welcome to our IoT Industry Bartalk. I'm very glad that you're here today. So we want to talk about your brewery of the future. What does it mean for you internally?
Okay, the brewery of the future is actually part of the overall supply chain transformation program of ABI. The program really aims to embrace the technology opportunities that Industry 4.0 is offering us. And actually our long-term dream is a future with a productive, flexible and sustainable brewery. A brewery that really brews superior beers that are really delighting our consumers across the world every single day.
Great. So when we take your vision now one step further, today we want to talk about the productivity, so to increase the productivity in your brewery. So what are your goals here?
We actually have very well-defined goals. But the key is that we define really where we want to go. And that's very, very important. We have that end vision and we're working towards that end vision. But within productivity, for instance, I could say, although it's of course of confidential nature, the overall program, but one thing is that we work towards, in fact, 100% inline quality control and process control.
Great. So when we take this goal maybe one step further, many companies of our IoT community are developing at the moment initiatives or use cases, as we say, to enable these goals. So do you have your top use cases for productivity for us here?
So in productivity, so we aim for inline quality and process control. This should allow us to take better decisions and faster decisions by the front line. In many situations, the technology allows us to do 100% inline control instead of spot control. And one example there is, for instance, the vision control of the best before date printed code. And actually, that allows us to avoid misprinted or missing prints going to the market and thus have defect products reaching our consumers.
Okay, so when we talk about a vision control use case, Manfred, you are our expert for smart sensors here. What is from your perspective important here and how does your smart sensors help WIM to get those initiatives done?
Yeah, so a smart camera or inspection camera system, of course, can generate a good bad decision of reading of an image in milliseconds, which is important for the process flow. But on the other hand, there are much more informations available in such a smart camera. So, for instance, you know exactly the reading quality, or for instance, the position of this best before date, where we read it, and these kind of data are also really valuable for quality improvement, for quality processes and for services in these regards.
Okay, so the next step would then be to make this valuable sensor data available in the next step. And Elmar, you are our network and control expert here. So what is from your perspective relevant to make those sensor data available in good quality in the next step? And how do you help WIM to create those initiatives?
Yeah, first of all, what I understood in the discussion is that WIM's dream or the vision of a brewery of the future is nothing else than a blueprint of a smart factory. And a smart factory needs a backbone, needs a very powerful network based on Ethernet in conjunction with a standardized communication technology. And we at B&R, we strongly believe that OPC-UA is exactly what is needed for. And therefore, we fully support or strongly support this technology. And we are not alone. So, for example, semiconductor manufacturers, big end customers, and also the biggest cloud companies worldwide are also supporting this idea.
Great. But now in these use cases, Wim was talking about like vision control. There are tons of data which has to be processed, and even in real time. So we are talking about real-time application. What is important from your perspective here to do that, to handle that data?
It's very important that the communication is fully deterministic, really from the cloud to the sensor. Why? Because I remember Wim told me that the operation speed from cans, for example, are today 180,000 cans per hour, which is 50 cans per second, so faster than any human eye. And that means that the data must really come to the right point, very accurate to exchange that information. And that is something which is now done by OPC extensions by introducing the so-called TSN profiles. TSN is time-sensitive networking. It's a buzzword, I have to mention it, but all in all, it ensures that the data, the urgent data traffic really is coming in the highest priority. And on the same cable, all the other information can also happen at the same time. And that is something which really fulfills the requirements to these high-speed applications.
So thank you, Alma. Now I want to make one step further to the sensor and the connectivity itself. So we talked about the sensor, we talked about the network. The next step would be to see how the connectivity is working. So Joachim, I guess you brought a sensor, so maybe we could have a look to that. What is important from your point of view, and how do you help Wim with his initiatives from Harting?
Yeah, so I think cabling is very important, because if we use more Ethernet sensors in the future, and cost-efficient cabling is mandatory. And how are those sensors, for example, here, like from company SIG, are they connected? So we have one cabling for power and one for communication. And the new technology of single-pair Ethernet can do the same job with just one single twisted pair. So it means with this new technology, we can enable company SIG to build smaller sensors, and ABI in the future to cut down the copper cabling needed really to a half.
Great. So thank you for pitching these technologies, even from you, Joachim and Manfred, Elmar. Thank you so much. I guess it's important to work together to help end customers like AB InBev to enable their initiatives from a technology perspective, and to work together as partners. So maybe to sum up in the last step, Wim, what is the secret from your perspective for enabling the productivity for your brewery of the future?
So one thing we know for sure is that the amount of sensors are going to go up in the coming years. And as a consequence, also the data will exponentially increase. So for us, that's key. But the real key is to transform that data into usable data that really empowers our frontline to take better decisions. And that will actually drive our productivity to the next level.
Great. Yeah.
Let's combine the strengths we have. This is connectivity, this is smart sensors, and also, of course, control, automation. And then we can, I think, fulfill the requirements of Wim in the near future.
Great. So maybe we should do a toast of it, right? To just maybe just grab a beer, grab a Corona beer, and I would say to future with more cheers.
Cheers.
Cheers. It was great to have you with us today, and special thanks to our 4 guests. You were awesome. So see you in the next episode when we talk about IoT use cases that increase flexibility. For more best practices from our IoT use case community or to discuss common starting points, please feel free to get in touch with the contact details in the description. To stay informed about the latest IoT projects or use cases, you can also subscribe to our IoT use case update and get a monthly overview. Cheers and see you in the next episode.